All right, so back into trigonometric functions, but this time we're going to look at it from a different lens than what we have in the past. Usually in geometry, we look at it in the terms of a right triangle, but here we're going to drop this into a unit circle. So let's go ahead and get started. Before we get too far, though, we do have to refresh our memories on some different facts that we need to be able to move forward. So one of the first ones I want to point out to you would be the whole 30, 60, 90 right triangles. And remember that in our understanding of right triangle trig, the sides opposite 30, that's going to be side length x. The hypotenuse was twice the shortest side length. This is x squared of 3. And then 45, 45, 90, both sides are the same, which makes sense because it's isosceles. And then based on the diagonal of a square, that would be x squared of 2 because it's the side length times the square root of 2 is the diagonal. Then we're going to take a look at what is sine, what's cosine, and we remember that in order to determine the sine of an angle, it's the opposite side over the hypotenuse. And in order to determine the cosine of an angle, it's the adjacent side divided by the hypotenuse. And since all of this is going to be on the unit circle, we've got to refresh our memory even about the equation of a circle. So if the center is at some point hk, this is our equation. But if I said to you, hey, you know what, well, all the stuff we're going to do is going to be centered at the origin. That means that h and k are 0, 0. So then we're down to the equation x squared plus y squared equals r squared. All right, so what does all of this have to do with the next part that we're dealing with in trig? Well, let's connect this to the previous learning I have. So we've gone through and we've talked about how here's my triangle, okay? And we've drawn triangles, but now let's also put in a unit circle. So a unit circle has a radius of 1. So this is for the unit circle. And that's why it has the name unit circle, because its radius is 1. So then if I look at this, then that means that this length is 1. And looking at the Pythagorean theorem, a squared plus b squared is going to be c squared. By the way, this is a right angle, of course, because given a right angle. So if I let this side be a, well, the difference is that, yes, this is side length a, but I'm on the x-axis, so let's just call it x. And then this would be side b, but since it's the length of whatever I am on the y, then that would be y. All right, and again, I know that this is the radius, and yes, I've said that the radius is 1, but let's now take a look here. So that means then within the unit circle, the equation a squared plus b squared equals c squared can be rewritten as the equation of a circle. So that's where it comes from, all right? So now with the stuff that we're doing, now we're also going to start talking about sine and cosine. So we know that the sine of some angle theta, which we'll call this spot theta, is equal to the opposite side, which would be y, divided by the hypotenuse, which is r. Well, we've told you that r is 1. So since r is 1, and I can just go ahead and then say, all right, well, then that means that y is going to be sine theta. Well, if I do cosine of theta, that is the adjacent side, which is x, divided by the hypotenuse, which is r. So this right here now, I know that this right here is going to be cosine of theta, and I know this right here is sine theta. Well, on my triangle, this point here, which is also a point on the circle, that point, if I'm on that circle, well, my x coordinate to get this point is cosine theta, and my y value is sine theta. So now that means anywhere that I am on the unit circle, any point, no matter what point I'm at, maybe I'm here, maybe I'm over here, maybe I'm down here, but we know that these points are cosine theta, sine theta, every single time. So my xy point on the circle is cosine sine. This is going to be very useful as we move forward, as the next couple examples will show. All right, so draw a 45-degree angle in standard position on the unit circle. All right, so 45-degree angle, so we'll go through, it's approximately like this. Again, I'm doing it by hand. And then here is 45 degrees, and 45 degrees rotates this way. And then I want to determine the sine and the cosine. All right, so then this is my reference triangle. This right here, this distance x and this distance y, that's going to tell me what sine and cosine are. So let's now go back, excuse me, and talk about the 45, 45, 90 triangle. So remember that my side lengths are the same, and this side length over here is x square root of 2. Well, this would be 45 degrees. So now if I think about that, then that means that the sine of theta, which is 45 degrees, we might as well just put in the angle, so sorry about that. So sine 45 degrees is equal to, well, the opposite side, which is x, divided by the hypotenuse, which is x square root of 2. That would be 1 square root of 2, but I can't leave square root of 2 in the denominator, so I multiply both numerator and denominator by square root of 2, and that gives us square root of 2 over 2. Cosine of 45 degrees is equal then to the adjacent side divided by the hypotenuse, which if you look, it's the exact same mathematics to all of it. So the nice thing is, with 45 degrees, they're the exact same value. So that means when I look over here, all right, well, this is square root of 2 divided by 2. This side length is square root of 2 divided by 2. So the point is actually square root of 2 divided by 2, square root of 2 divided by 2. And again, all of these things relate to each other. All right, so we're going to be pulling in, because depending upon what information you're given, you got to either determine sine or cosine from an angle. Maybe it's a point, and you got to work in reverse. All right, so we're using this information to determine sine and cosine, and we're making our drawings within. All right, let's do another example. In this case, it says draw pi over 6 in standard position. Now, if you don't remember what pi over 6 looks like, remember we can do the conversions. We can change something from radians to degrees. And if you do, then you would know that this is a 30-degree angle. So I'm going to try my best to draw a 30-degree angle. All right. So now this angle, which I'm going to do an arrow into there because it's tough to see, but this would be pi divided by 6. All right, so opposite of a 30-degree angle, okay, that's going to be this side. So now if I go through and I look at my triangle, and I call this 30 degrees, and I call this 60 degrees. Remember, the side opposite 30 is x. So the hypotenuse was 2x, and this side was x square root of 3. So if I go through then and do my mathematics here, I want to again be back into this triangle. So I've got to remember that I'm on a unit circle. This helps me to figure out the ratios. So I know that the hypotenuse is 1. So I'm going to show you a different way to go through and figure out your values. So if the hypotenuse is 1, well, that's what 2x equals, which then means x is equal to 1/2. So this side length is 1/2. And then if I go through and figure out, all right, well, if x is 1/2, that's this side, then I need x times the square root of 3. Well, 1/2 times square root of 3, this is the square root of 3. Sorry, it looks like a j, but it's the square root. Square root of 3 divided by 2. So those are the relationships on a side with the sides for a 30, 60, 90 right triangle. Now we know that this point location is cosine theta sine theta. So that means that my x part is cosine. So then cosine of pi divided by 6 is equal to square root of 3 divided by 2. Then we know sine of pi divided by 6 is equal to this side length, which is 1/2. All right, so a couple different ways at which to go through and get our values. So either I go through and I deal with the triangle on the outside, or I go through and I figure out what x is and solve in that manner. But eventually you're going to use this so much that it's going to be stuck there whether you want it there or not. All right, next one. Draw a 90-degree angle in standard position. Okay, so then that means it's going to be, well, it's tough to draw it perfectly. You get the idea. All right, so that's a 90-degree angle. Technology, it's great. All right, so that's a 90-degree angle. It's supposed to be on the positive y-axis. So now that's my 90-degree angle. Well, I can't draw a triangle. And a lot of times students try to make the triangle by drawing it through here. No, please don't do that. But what I do know is I know this location. That location is 0 on the x and 1 on the y because, again, this is the unit circle. Well, that first value, remember, every single point, x and y, is cosine theta, sine theta. So if I'm at 90 degrees, and not where my line is drawn, if I'm at 90 degrees, then that means cosine of 90 degrees is equal to 0. And that means the sine of 90 degrees is equal to 1. So here's what I was saying, where if you're given the points, well, it's a lot easier for a 90-degree angle to go off of the point, and then from that point you can determine what sine and cosine are. So you draw it, you know where that point is on the circle, the unit circle, and then go from there. All right, so this is just 3 examples. What we're going to do in the next video is I'm going to drop these angles into different quadrants and then go from there. But right now, this is what it looks like to start determining what the sine and cosine values are off of a unit circle. So hopefully this was helpful, at least to get you started with thinking about sine and cosine within the unit circle. Again, if this is useful, helpful, and everything else along those lines, go ahead and subscribe to the Charahoe Pre-Calculus YouTube channel, and visit back often for any updates. All right, thank you, and have a great rest of your day.